Okay, the first question is to find the volume of hydrogen needed to react with 3.55 grams of chlorine at standard temperature and pressure. So we are given the balanced equation, which is H2 gas plus Cl2 gas gives 2HCl gas. We make sure that the equation is balanced first before we do any calculations. We have to list the given, the required to find first. So the given is the mass of chlorine is given to be 3.55 grams. The required to find is the volume of hydrogen that is needed to react with this mass of chlorine at standard temperature and pressure. So we have to find the volume in decimeter cubed of hydrogen that is needed in this reaction. So I copied out the equation again, balance, and we need to write the most convenient ratio and the given from the equation before we can cross multiply to get our answer. So the ratio and our given are in two separate rows underneath the equation itself. We go back to the equation and we read the given. The given of the chlorine is 3.55 grams. So under chlorine in the equation, we write 3.55 grams. Under hydrogen, we write question mark because we need to see how many decimeter cubed of hydrogen is needed to react with this specific mass of chlorine. So we go to our equation and we write our most convenient ratio in the same units as the given. So under hydrogen, we write the volume of 1H2 at STP. So the volume of 1 mole of a gas at STP is 22.4 decimeter cubed. Then under chlorine, we write its mass in grams according to the balanced equation. In our balanced equation, we have 1 Cl2. The mass of 1 Cl2 is 35.5 times 2. So what we did now is we wrote the ratio, the most convenient ratio, and the given in the second row. Next step, we cross multiply to get our unknown value. So the volume of hydrogen needed will be 22.4 times 3.55 over 35.5 times 2. So if you use your calculator to get the value of the volume, you will see that the volume of hydrogen gas will be 1.12 decimeter cubed. We can put a box around our answer and then check that we reported our answer to the correct number of significant figures. Looking back at the given, we are given one number, which is the mass of chlorine, and its value was 3 significant figures. So our final answer should be reported to the least number of significant figures in our given, so it should be as well 3 significant figures. So our answer is correct, 1.12 decimeter cubed. Okay, the next question is to find the number of moles of Fe2O3 produced when 2.8 grams of iron reacts with oxygen. So the balanced equation here is given to you. 4 Fe solid plus 3 O2 gas gives 2 Fe2O3 solid. So our equation is balanced. We can move on to write the given and the required to find. So if we go back to our question, the given is the mass of iron is given in the question to be 2.8 grams. Required to find is the number of moles of Fe2O3 that will be produced when this mass of iron reacts with the oxygen in the equation. So I rewrote the equation out. 4 Fe solid plus 3 O2 gas gives 2 Fe2O3 solid. The next step, we have to write the ratio in the most convenient form and the given before we can do any cross multiplication. So the first step is to write our given under each term from our original question. So the given here is 2.8 grams of iron. So under iron, I write 2.8 grams. We want to find the number of moles of Fe2O3 that forms. So under Fe2O3, I put a question mark, how many moles? We go back to our equation and we write the ratio in the same units as the given. So according to our equation, we have 4 Fe's. Each Fe, according to the periodic table, has a mass of 56. So 4 times 56 grams gives us, according to the equation, 2 moles of Fe2O3. So 2.8 grams will give us how many moles? So we do a simple cross multiplication to get the number of moles of product formed. So number of moles of Fe2O3 will then be equal to 2 times 2.8 divided by 4 times 56. So if we go to our calculators, we can see that the answer will be 0.025 moles. Again, we check if our answer is reported to the correct number of significant figures. If we go back to our given, the number given is 2.8, which is 2 significant figures. So our final answer should also be reported to 2 significant figures, which is 0.025, which is correct, because zeros to the left do not count as being significant. So this is correct to 2 significant figures. Okay, next question. Find the mass of CH3COOH needed to react with 40 grams of oxygen. The balanced equation is given. CH3COOH plus 2O2 gives 2CO2 plus 2H2O. We write the given first. So the mass of oxygen given is 40 grams. The required to find in the question is the mass of CH3COOH needed to react with this mass of oxygen that's given. We rewrite the equation, and under it we write the ratio in the most convenient form and the given from the original question. So we go back to the question, we write the given in the second row. The given is mass of oxygen is 40 grams. So under oxygen, we will write 40 grams. Under CH3COOH, we want to find out the mass that will react with the oxygen. So we put question mark, how many grams? From our equation, we write the ratio in the same units, which are mass units, grams and grams. So from our equation, I have 1 CH3COOH. If we go to the periodic table and we add the masses of these atoms, we find out that the mass of 1 CH3COOH is 60 grams. We go to the oxygen in the equation. There are 2 O2s. Each O has a mass of 16. So 16 times 2 is 32, times 2, 64. So 2 O2s has a mass of 64 grams. So from our equation, 60 grams reacts with 64 grams of oxygen. The question is, how many grams will react with 40 grams of oxygen? So again, it's a simple cross multiplication from this ratio and given. So the mass of CH3COOH that will react with the 40 grams of oxygen will be 60 times 40 divided by 64. So you will get an answer of 37.5 grams if you do that on the calculator. But then you have to go back to the original question and report to the correct number of significant figures, which should be 2, because 40 grams is 2 significant figures. So we have to report our answer to 2 significant figures. 37.5 is 3 significant figures. So we should round this answer to 2 significant figures, which we will get an answer of 38 grams. Okay, the next question is to find the mass of water produced when 35 grams of C5H10 burns in oxygen gas. The balanced equation is given in the question to be 2 C5H10 plus 15 O2 gives 10 CO2 plus 10 H2O. Again, we write the given and the required to find. The given from the question is the mass of C5H10 equals 35 grams. We are required to find the mass of water, which is a product that will form when this mass of C5H10 reacts with oxygen. So we rewrite the equation in its balanced form, and we write the ratio in its most convenient form and the given from the original equation. So the given from the original equation is 35 grams of C5H10. So under C5H10, I'll write 35 grams. The required to find is the mass of water that will form. So under water, we write how many grams. We go to our equation and we write the ratio in the same units. So grams for C5H10 and grams for H2O. The mass of 2 C5H10s, if you go to the periodic table and you count, each C has a mass of 12. Each H has a mass of 1. So 12 times 5 is 60, plus 10, 70, times 2, 140. So you end up with 140 grams of 2 C5H10. Gives us 10 waters. Each water has a mass of 18 grams because 2 plus 16 gives you 18. So 10 times 18, you end up with 180 grams. So according to our equation, when 140 grams of C5H10 react, they will give us 180 grams of water. The question is, if 35 grams react, how many grams of water do we get? So again, we do a simple cross multiplication and we report our answer to the correct number of significant figures. So the mass of water that forms equals 35 times 180 divided by 140. So we end up with an answer of 45 grams. We'll go back to the original given and we check if our answer is reported to the correct number of significant figures. And it is correct because it should be reported to 2 significant figures. And here our given is in 2 significant figures. So the answer is 45 grams. Okay, find the heat produced when 1.00 grams of hydrogen reacts with oxygen. The balanced equation with the heat term is given. 2H2 gas plus O2 gas gives 2H2O. Plus 572 kilojoules. So this is the energy term in the equation, and since it's on the right side, it means heat is produced in this reaction, and 572 kilojoules of heat are produced when 2 moles of hydrogen react with 1 mole of oxygen to give 2 moles of water. So we write the given and the required to find. The given from our original question is the mass of hydrogen is given to be 1.00 grams. The required to find is the heat produced in this reaction. So the heat produced is how many kilojoules. We rewrite the equation and we write the ratio in its most convenient form and the given, and then we cross multiply to get our final answer. So under the given, we write what's given in the question, which is the mass of hydrogen. So under hydrogen, we write the given, which is 1.00 grams. They want us to find the energy produced. So under the energy term in the equation, we put a question mark, so how many kilojoules will be formed. Our ratio from the equation should be in the same units. So the units of hydrogen should be grams. 2 H2s has a mass of how many grams? You go back to the periodic table and you check. Each H has a mass of 1. So 1 times 2 times 2. So that is 4 grams. 4 grams of hydrogen will give us 572 kilojoules. So 1 gram of hydrogen will produce what amount of heat? We do a simple cross multiplication. When we cross multiply, we will end up with the energy produced to be 572 times 1 divided by 4. So we end up with an answer on the calculator. So you end up with 572 divided by 4. You will end up with 143 kilojoules. We go back to the given and we check if it's reported to the correct number of significant figures. The given is 3 significant figures, so our final answer should be reported to 3 significant figures, which is correct. 143 kilojoules. Okay, find the mass of C4H10, which burns with 2.6 moles of oxygen. The balanced equation is given below. 2 C4H10 plus 13 O2 gives 8 CO2s and 10 waters, H2O. We write the given and the required to find. The given is the number of moles of oxygen is 2.6 moles. The required to find is the mass of C4H10 in grams that will react with this many moles of oxygen gas. So we rewrite the balanced equation and we write the ratio and the given from our balanced equation, the ratio in its most convenient form. So the given is from the question, so 2.6 moles of oxygen, we write that under O2 in the balanced equation, will react with how many, so question mark, how many grams of C4H10. So the ratio from our equation should be in the same units, which is grams and moles here. So we go to our equation and we write the values according to the units that are in the given. So grams and moles. 2 C4H10s have what mass in grams? We go back to the periodic table and we calculate. Each carbon has a mass of 12 and each hydrogen has a mass of 1. So 12 times 4, which is 48, plus 10, 58, times 2, so you'll end up with 2 times 58 because each C4H10 has a mass of 58 grams. From our equation, we have 13 O2s, so that's 13 moles. So from our equation, we wrote a mixed ratio. 2 times 58 grams will react with exactly 13 moles of oxygen. So how many grams will react with 2.6 moles? So we do a simple cross multiplication to get the mass of C4H10 that will react with the oxygen. So the mass of C4H10 that will react with the 2.6 moles of oxygen will be 2.6 times 2 times 58 divided by 13. So if you go to your calculator, you will end up with 23.2 grams. Again, we go back to the given. The given is 2.6 moles, which is 2 significant figures. So our final answer has to be reported to 2 significant figures. So we have to round this answer, which is 3 significant figures, down to 2. So it will be 23 grams. So the final answer will be 23 grams. Find the heat produced when 0.0250 moles of hydrogen reacts with oxygen. The equation with the heat term is given below. 2H2 plus O2 gives 2H2O plus 572 kilojoules. So according to the equation given, 572 kilojoules are released in this reaction when 2 hydrogens react with 1 mole of oxygen to give 2 moles of water. So we write the given. Given number of moles of hydrogen equals 0.0250. Required to find is the heat produced when this many moles of hydrogen reacts with oxygen according to the equation. So the required to find is the amount of heat produced in kilojoules. We write our equation again, and then we write the ratio and the given from the original question. So the given from the original question is 0.0250 moles of hydrogen gas. So under hydrogen, we write 0.0250 moles. Under hydrogen. Then under the energy term, we write how many kilojoules will be released when this many moles of hydrogen reacts completely. From our equation, we write the ratio in the most convenient form. So we write our ratio using moles for hydrogen. According to our equation, we have 2 H2s. So we write 2 moles of H2 will react completely to give us 572 kilojoules of energy. So if we burn 0.0250 moles, how much energy will be produced? We do a simple cross multiplication and we get the heat produced in this reaction equals 572 times 0.0250 over 2. So if you go to your calculator and you do this reaction, you're going to end up with 7.15 kilojoules. Let us check if our answer is to the correct number of significant figures. If we go back to our original given, the number that we used is 3 significant figures because zeros to the left don't count. And our final answer is also reported to 3 significant figures, which is 7.15 kilojoules. Balance the equation below, keeping the coefficient of C3H6 as 1. Because in the equation given, they already specified that they want the coefficient of C3H6 in the final balanced equation to remain as 1. So we have to add coefficients here to balance the equation without changing the coefficient of C3H6. So as we know that atoms have to be conserved in a chemical reaction. So we have to count how many carbon atoms do we have on the left, and it should be equal to the number on the right. Same with hydrogen and oxygen. So if we look at the left side of this equation, we have 1 C3H6. 1 times 3 is 3. So we have 3 carbon atoms on the left side, and we only have 1 on the right. If we don't write anything, we mean 1. But we need to make them equal, so I will place a 3 behind the CO2 to make the number of carbon atoms 3, which is the same as the left side of the equation. We do the same for hydrogen. On the left side, we have 6 H atoms. So on the right side, I must make the number equal to 6. But we only have 2 in each water molecule. So to make it 6, we need to multiply by 3. So when we place a 3 here, 3 times 2 is 6. We have 6 hydrogen atoms on the right. We leave oxygen till the last because it is present in most of the reactants and products. Now, after we balance the carbon and hydrogen, we can count the oxygens and balance it accordingly. So on the right side, we have 6, 3 times 2, 6 O's in 3 carbon dioxides, and 3 times 1 is 3, 3 O's in the water. So in total, we have 6 and 3, 9. So how am I supposed to add a coefficient here to make the total number of oxygen atoms equals to 9? O2 has 2. So I must multiply 2 by a number to make it 9. What times 2 equals 9? 9 over 2. Or you can use 4.5, which is the same. So 9 over 2 oxygens. 9 over 2 times 2 is 9, and then you have 6 and 3, 9 on the right side, so the total number of atoms are conserved now. Find the number of moles of carbon dioxide produced when 0.10 moles of C2H6 burns with oxygen gas. The equation is given below. 2C2H6 plus 7O2 gives 4CO2 plus 6 H2Os. The given is 0.10 moles of C2H6. Required to find is the number of moles of carbon dioxide produced when this many moles of C2H6 will burn completely in oxygen. We rewrite the equation below. We write the ratio in the most convenient form and the given from our balanced equation. The given is from the original question, which says 0.10 moles of C2H6 is going to burn in oxygen. So under C2H6, I write its given, which is 0.10 moles. They want us to find how many moles of carbon dioxide will be produced. So under carbon dioxide, we write question mark, how many moles? From our equation, we write the ratio in the same units, so moles and moles. How many moles do we have from our balanced equation? 2 moles of C2H6, the coefficient is 2, so 2 moles will give us 4 moles of carbon dioxide. According to our balanced equation, the coefficient of CO2 is 4. So 0.10 moles will give us how many moles if completely burnt? We do a simple cross multiplication. So the number of moles of CO2 that will be produced equals 4 times 0.1 over 2. So 4 times 0.10 over 2. So you will end up with 0.20 moles. We need to check with our original given that we reported to the correct number of significant figures. I have 0.10 in the given, which is 2 significant figures, the zeros to the left don't count. So my final answer is also reported to 2 significant figures, which is correct. Find the volume of air needed to burn 0.200 moles of C2H6 at standard temperature and pressure. STP means standard temperature and pressure. We know that under standard temperature and pressure conditions, 1 mole of any gas will occupy 22.4 deciliter cubed or meters. The equation is balanced and given below. 2C2H6 plus 7O2 gives 4CO2 plus 6H2O. The given is the moles of C2H6, which is given to be 0.200 moles. Volume of air needed, we need to find how many liters or deciliter cubed of air is needed to burn 0.2 moles of C2H6 completely. So we rewrite the equation below. In our equation, we do not have air as a reactant. We have oxygen, but it is necessary to find the volume of oxygen needed before we can find the volume of air, because we know that air is 20% oxygen, and we can get the volume of air once we know the volume of oxygen that's needed. So we write our ratio and our given. The given is from the original question, which is 0.200 moles of C2H6. So the given is 0.200 moles of C2H6. So I wrote it under C2H6. We are required to find the volume of air needed. We do not have air in the equation, but we need to get the volume of oxygen needed to burn this many moles before we can get the volume of air. So under oxygen, I will write question mark, how many deciliter cubed of oxygen is needed to burn this many moles of C2H6. So I go to my equation and I write the ratio in the same units. So moles for this and deciliter cubed for O2. From my equation, we have 2 C2H6s, so 2 moles. And we have 7 O2s, which is what volume at STP? It is 7 times 22.4, because each mole of a gas at STP occupies 22.4, and we have 7 in the balanced equation. So what we do now is again a simple cross multiplication, and we get the volume of oxygen needed. So the volume of oxygen needed equals 7 times 22.4 times 0.200 divided by 2. So if you go to your calculator and you get the volume of oxygen needed, you will end up with 15.68 deciliter cubed. The question is requiring to get the volume of air. So how do we get the volume of air from the volume of oxygen? Since we know that air is 20% oxygen, it means that the volume of air will always be 5 times the volume of oxygen needed. So volume of oxygen we found, we multiply that by 5, we will end up with 5 times 15.68. So you end up with 78.4 deciliter cubed. We go to the given and we check if our answers to the correct number of significant figures. It's correct because this is 3 significant figures, and our final answer is also 3 significant figures. Find the volume of N2 formed at STP when 3.20 grams of oxygen reacts with N2H4. The reaction is given below and balanced. N2H4 gas plus O2 gas gives N2 gas plus 2H2O gas. Given mass of oxygen is given to be 3.20 grams. Required to find is the volume of N2 that's formed. So how many decimeter cubed of N2 will be formed when 3.20 grams of oxygen reacts? So the balanced equation is given below. N2H4 gas plus O2 gas gives N2 gas plus 2H2O gas. Our given is from the original question. So the given is 3.20 grams of oxygen. So under oxygen, we will write 3.20 grams. And we are required to find the volume of N2 formed at STP. So under N2, I'll put question mark and how many decimeter cubed. So we write our ratio from our balanced equation in the same units. So grams for O2 and decimeter cubed for N2. So according to our equation, the coefficient of O2 is 1. The mass of 1 O2 is 16 times 2, which is 32 grams. Will always give us, 32 grams of O2 will always give us 1 N2, which has a mass of 14 times 2, which is 28. But we need to write the volume since our question is asking for how many decimeter cubed. So we need to write the volume ratio for N2. 1 N2 at STP will occupy 1 times 22.4, which is 22.4 decimeter cubed. So from my equation, I do a simple cross multiplication to get my final answer. So the volume of N2 needed equals 22.4 times 3.20 over 32. So 3.2 over 32 times 22.4, you end up with 2.24 decimeter cubed. If we check our answer to see whether it's reported to the correct number of significant figures, we see that it's correct because it should be 3 significant figures according to the given, which is also 3. So our final answer will be 2.24 decimeter cubed. Find the number of moles of CH4 needed to react with 44.8 liters of oxygen, again at standard temperature and pressure, which is STP. The equation is balanced and given below. CH4 plus 2O2 gives CO2 plus 2H2O. The given is the volume of oxygen is 44.8 liters at STP. The required to find is how many moles of CH4 will react with this volume of oxygen at STP. So we rewrite the equation and we write the ratio and our given underneath. The given is from the original question. So the given is 44.8 liters of O2. So under O2, I will write 44.8 liters or decimeter cubed, which is the same thing. Under CH4, I will write question mark as in how many moles will react with this volume of oxygen. So we will write our ratio in the same units as the given. Moles for CH4 and liters or decimeter cubed for O2. So from our equation, we have 1 CH4, so 1 mole of CH4 reacts with 2 moles of O2. 2 moles of a gas at STP occupies a volume of 2 times 22.4. So then we do a simple cross multiplication. 1 mole gives us needs 2 times 22.4 liters. So how many moles will react with 44.8? We do a simple cross multiplication. So number of moles of CH4 equals 44.8 times 1 over 2 times 22.4 to give us a final answer of 1 mole. But looking back at the given, our final answer should be reported to 3 significant figures. So our final answer should be 1.00 moles. Find the mass of C5H10 that reacts with 30.0 moles of oxygen. The equation of combustion is given below. 2 C5H10 reacts with 15 O2s to give 10 CO2s plus 10 waters. Given number of moles of oxygen equals 30.0 moles. Required to find is the mass of C5H10 that will react with the 30 moles of C5H10. We rewrite the equation in its balanced form, and we write the ratio in its most convenient form and the given from the original question, and we cross-multiply to give us our final answer. So the given from our original question is 30.0 moles of O2. So under O2, I will write 30.0 moles. We are required to find the mass, so grams, of C5H10 that is needed to react with this many moles of oxygen. So under C5H10, I'll write question mark, how many grams, because we are required to find the mass. From our balanced equation, we write the ratio in the same units. So for C5H10, we want to write its mass, and for O2, we want to write the number of moles. So from our equation, 2 C5H10s have a mass of how many grams? Each C has a mass of 12, and each H has a mass of 1. So 12 times 5 is 60, plus 10, 70, times 2, 140. So 2 times 70 grams reacts with 15 moles from the equation because the coefficient of O2 is 15. So how many grams will react with 30 moles? We do a simple cross multiplication to get the mass needed. So the mass of C5H10 needed to react equals 2 times 70 times 30 divided by 15. If you do that on the calculator, you will get your final answer to be 280 grams. We go back to the original given and we check if it's reported to the correct number of significant figures, which is 3 in the original given, and our answer is already in 3 significant figures, which is 280 grams. Find the number of moles of KCl formed when 7.1 grams of chlorine react. The balanced equation is given below. 2K solid plus Cl2 gas gives 2 KCl solid. The given is the mass of Cl2 equals 7.1 grams. Required to find is the moles of KCl that will form when 7.1 grams of chlorine reacts completely with the potassium. The equation is rewritten below. We write our ratio in the most convenient form and the given from the original equation. According to our original question, our given is 7.1 grams of chlorine. So under chlorine, I will write 7.1 grams. we are required to find how many moles of KCl will react with this mass of chlorine. So under potassium, I will put question mark, how many moles. From our equation, we write the ratio in the same units as the given. So for K, we'll write it in moles, and for Cl2, we'll write it in grams. According to our equation, the coefficient of K is 2, so this is 2 moles of potassium reacting with 1 mole of chlorine. The mass of one Cl2, according to the periodic table, each Cl is 35.5. So Cl2 will have a mass of 35.5 times 2, which is 71. Now we can cross multiply and get our final answer. So the number of moles of potassium that are needed to react with the 7.1 grams of chlorine equals 2 times 7.1 divided by 35.5 times 2. If you do that on the calculator, you will get your final answer to be 0.20 moles. Let us check if it is reported to the correct number of significant figures. Our given is 7.1, which is 2 significant figures, and our answer is reported to 2 significant figures because the 0 to the left is not significant. Find the volume of oxygen needed to react with 0.800 moles of C2H6. The balanced equation is given below. 2 C2H6 plus 7 O2 gives 4 CO2 plus 6 H2O. The given is from the question above. The number of moles of C2H6 is given to be 0.800 moles. The required to find is the volume of oxygen that's needed to react with 0.8 moles of C2H6 at STP. So we rewrite the balanced equation below, and under the balanced equation we have 2 rows. We have the ratio and the given. The given is from the question above, 0.800 moles of C2H6. So under C2H6, we write 0.800 moles. Under O2, we want to find the volume of oxygen, so we put a question mark, as in how many decimeter cubed. The ratio, we should write it in the same units as the given. So for C2H6, we have to place moles, and for O2, we have to write the ratio in decimeter cubed. So looking at the balanced equation, we have 2 C2H6, so we have 2 moles of C2H6 that react with 7 moles of oxygen. The question says that the reaction is at STP, and 7 moles of a gas at STP will occupy 7 times 22.4. So 2 moles will react with 7 times 22.4 decimeter cubed. So 0.8 moles will react with what volume of oxygen? We do a simple cross multiplication to get our final answer. So the volume of oxygen that's needed equals 0.800 times 7 times 22.4 divided by 2. So if you use your calculator, you'll get your final answer to be 62.72 decimeter cubed. We need to look at the given to check whether we reported our answer to the correct number of significant figures. In the given, the number of significant figures is 3 because zeros to the left don't count. So our final answer should be 3 significant figures. In this form, it is 4, so we have to round to 3. So our final answer will be 62 0.7 decimeter cubed, which is 3 significant figures. Find the heat produced when 73.0 grams of HCl are produced by the following reaction. The reaction is given below, including the heat term. H2 gas plus Cl2 gas gives 2 HCl gas plus 334 kilojoules. The equation shows that the energy term is on the right side, meaning that this reaction releases 334 kilojoules when 1 mole of H2 reacts with 1 mole of Cl2 to give 2 moles of HCl. The given is the mass of HCl is 73.0 grams. What we're required to find is the heat produced in kilojoules. So we rewrite the equation as it is above, and we write the ratio and the given. The given is from the question above. So the given is 73.0 grams of HCl. So under HCl, we write the given, which is 73.0 grams. The required to find is the heat produced. So under the energy term, we write question mark, how many kilojoules are produced when this many grams of HCl are formed. So we go to our equation and we write the same units in our ratio in the most convenient form. So according to our equation, we have 2 HCl. 2 moles of HCl have a mass of 2 times HCl. H is 1, Cl is 35.5. So 36.5 times 2. And the energy term is 334 kilojoules. So according to our equation, 2 times 36.5 releases 334 kilojoules. So 73.0 grams will release how many kilojoules? We do a simple cross multiplication. So the energy produced in this reaction equals 73.0 times 334 divided by 2 times 36.5, and if you do it on the you end up with 334 kilojoules, because this is 73 grams and the given is 73 grams, so the energy released will be the same, which is 334 kilojoules. We go back to the original question and we check if our answer is correct to 3 significant figures. Our given is also 3 significant figures, so our final answer is correct, which is 334 kilojoules. Find the number of moles of NO2 gas formed when 2.24 liters of NO are reacted with 8.0 grams of oxygen. So we are given 2 reactant givens, and we are required to find the moles of one of the products that is formed. So the first given is the mass of O2 gas is 8.0 grams. It's going to react with 2.24 liters of NO gas at STP to form products. The required to find is the number of moles of NO2 that will be formed by this reaction. So we need to write the balanced equation first, which is 2NO gas plus O2 gas gives 2NO2 gas. There are 2 rows which will be written under this reaction. The first row is the convenient ratio from your equation that we are going to use, and the second row is the given from the original question. So if we go back to our question, let us write the given in the second row under the relevant reactants and products. So the mass of oxygen gas is given to be 8.0 grams. So under oxygen gas in the second row, we will write 8.0 grams. Volume of NO is 2.24 liters. So under NO, in the given row, we write 2.24 liters, which is the same as decimeter cubed. And we are required to find how many moles of NO2 will form from this reaction. So under NO2, we'll put question mark as in how many moles. We go back to our equation and we write the ratio in the same units as the given. So for NO, we want to write in liters, for O2 grams, and for NO2 in moles. So from our equation, we have two NOs that are going to react with 1 mole of O2. So 2 NOs has a has a volume of 2 times 22.4 liters, because each mole of a gas at STP occupies 22.4 liters. And 1 O2 has a mass of 16 times 2, which is 32 grams. So according to my equation, 2 times 22.4 liters of NO will react exactly with 32 grams of oxygen to give me 2 moles of NO2, because the coefficient of NO2 is 2. So now we wrote our ratio that is in the same units as the given. The next step is to find out which of the two reactants is in excess and which one is the limiting reagent, so as to know which one are we going to use to get the amount of product formed. So the next step is to find out which reactant is the limiting or the excess reagent. The way to do that is to do the hiding method. What we mean by the hiding method, we will hide one given value out of the two, and we will solve for it as though it is not there. So for example, let us cover the oxygen mass, and let us solve using the other given value. What is the mass of oxygen that will react with 2.24 liters of NO? So we cover the O2 mass and we solve for it as though it is not there. So what we will do now is we will solve for that mass. So the mass of O2 that will react with the NO given is, so we'll assume the 8 grams is not there, and we'll solve to see how much is actually going to react, equals 2.24 times 32 divided by 2 times 22.4. So if you use your calculator, you will end up with 1.6 grams. So what does this value mean? The 1.6 grams is the mass of oxygen. So if we cover the 8 grams and we solved for it, we got 1.6. That means that the 2.24 liters of NO are only going to react with 1.6 grams of oxygen. But we have 8 given. But out of the 8, only 1.6 will react. So that means I have more oxygen than what's going to react. So this means that O2 is the excess reagent. I have more of it than what's actually going to react. So to be left behind in the reaction. And that means that the NO will be the limiting reagent. What we do next is we cross out the excess reagent, which we found out to be the O2, and we use the limiting reagent to get our product. So the last step would be to cross multiply using the limiting reagent, which is NO, to get the number of moles of product formed. So the number of moles of NO2 formed will be 2 times 2.24 over 2 times 22.4. So these cancel out. This is going to end up to be 0.10 moles. If we go back to the original given, we have 2 numbers. This one is 3 significant figures. 2.24 is 3 significant figures. 8.0 is two significant figures, so we always report to the least number of significant figures in our given, which is 2. So 0.10 moles is two significant figures, and it will be the correct answer. Find number of moles of Cl2 present in 0.71 grams of Cl2. So we are given the mass of chlorine, which is Cl2, it's diatomic, equals 0.71 grams. We are required to find the number of moles of Cl2 present in that mass. We know that there is an equation that relates the number of moles of a substance to its mass. That equation is N equals M over capital M. What is meant by this equation? N is the number of moles of the substance, which is what we are required to find. Small m is the mass of that substance given. Capital M is its molar mass, which you get from the periodic table. So the number of moles here equals the mass, which is given to be 0.71, divided by the molar mass. Now the molar mass of chlorine equals, from the periodic table, Cl's atomic mass is 35.5. So Cl2, its molar mass will be 35.5 times 2, because it's a Cl2, which is equal to 71 grams per mole. So when we go back to this equation, the mass is 0.71 grams, which is given. The molar mass of Cl2, which we found here, to be 71 grams per mole. And then the units cancel out, and you end up with a mole unit, which is 0.71 over 71. So you end up with 0.010 moles. If we look at our given, the given is in two significant figures. So our final answer should be two significant figures. Zeros to the left don't count, so our final answer is correct. 0.010, which is two significant figures. Find the number of moles that are found in 1.5 times 10 to the power 23 molecules of a substance. So we are given the number of molecules to be 1.5 times 10 to the power 23. We are required to find how many moles are present in this many molecules. So we know a relation between number of moles and number of molecules. We know that 1 mole of a substance is equivalent to 6.0 times 10 to the power 23 molecules, which is Avogadro's number. So this question can be answered by a simple conversion factor. So we have 1.5 times 10 to the power 23 molecules. We want to change it to number of moles. So we multiply by a simple conversion factor, which relates the number of moles of a substance to the number of its molecules. We know that 1 mole of a substance is equivalent to 6.0 times 10 to the power 23 molecules. So if we multiply by this conversion factor, the molecules unit cancels out, and we end up with the number of moles of our substance by a simple division. So 1.5 times 10 to the power 23 over 6 times 10 to the power 23, these cancel out, and 1.5 divided by 6 is a quarter. So you end up with an answer of 0.25 moles. Now we can check with the given above if our number of significant figures are correct. It is correct. So our answer is 0.25 moles.